Welcome to Homework Lib.
Hi. In this video, we have a function h such that we're given a few things. We know that h of 4 is negative 3, and we know that h prime of x is equal to x squared minus 2 over 2, x squared minus 2 over x, and x is non-zero. So first we want to find all the values for which the h has a horizontal tangent. So the key here is just that this is the same as saying that h prime of x is 0. So all we need to find is when x squared minus 2 over x is equal to 0. But that can only happen if x squared minus 2 is equal to 0. And so that's at x equals plus or minus the square root of 2. So then for each of these we want to say whether it's a local max or min. So we look at a number line for h prime of x, and we mark all of the critical values. And in this case that's going to be negative root 2, 0, and root 2. And we include 0 because 0 is an undefined point, and that's considered a critical number. And then we plug in points in all of these different regions. So we plug in maybe negative 2, negative 1, 1, 2. And what we see is that in each of these regions, we get the sign of h prime. Or I should say, we plug in these numbers and the sign of it determines whether h prime is positive or negative in that entire region. And that's because h prime can only switch signs when it passes through 0. And we've marked all the points where h prime could possibly switch signs. But anyway, so we plug in 2 and we get a positive number, so h prime is positive here. If we plug in 1, we get a negative. If we plug in negative 1, we get a positive. And if we plug in negative 2, we get a negative. So this roughly means that our graph is decreasing and then increasing, and then decreasing, and then I guess I should do it more in line with the x-axis here. So it'll be decreasing and then increasing, decreasing, increasing. So h will have a shape like this, which means that both of our points are local mins. Okay. So that's it for A. Then we move on to B, where it says write an equation for the tangent line at x equals 4. So that's just going to be we just need the slope at x equals 4 because we already know the point is 4 comma negative 3 from up here. So we just say h prime of 4, that's going to be 16 minus 2 over 4, so 7 over 2. And so our tangent line is going to be y plus 3 is equal to 7 over 2 times x minus 4. And then finally, we're asked whether the tangent line to the graph at whether it lies above or below the graph at x greater than 4. So the key to this one is we need to determine the concavity of h at x equals 4. And the concavity of h is determined by its second derivative, h double prime of x. So we take the derivative of h prime using the quotient rule, and we get x times 2x minus x squared minus 2 over x squared. And if we plug in 4, we get 32 minus 14 over 16. And the important thing is just that this is a positive number. And so therefore, we are concave up at this point, which means our function looks like this. And for any tangent line, when you're concave up, you'll notice it's always below the graph. So the answer is below the graph. And we're done.